Hello, so welcome to another session of Sherlock. I'm going to explain the search functionality that is present in Sherlock right now. So let's go to Sherlock's command line, Sherlock shell. Now the search is pretty rudimentary right now, but it has a lot of scope to be improved in the coming versions of Sherlock. I just wanted to keep it minimal and functional as of now. I'm going to explain both the front end as well as the back end aspects of Sherlock. Um, I mean the search functionality of Sherlock. So let's go ahead and invoke Sherlock shell. Okay, so here we select the fourth option, which is search, and I'm going to exit out of search. That will bring me back to the main menu of Sherlock. Let me go back to search again, and here what I want to do. Here what I would like to search for a specific term that I have given in one of the notes for one of those projects in one of those earlier projects. So um, this particular term is not available anywhere in the data that has been gathered so far, or the labels that have been given to the um, sessions or um, site names or project names. So this term is a unique term. I mean, if you remember the name of if you remember the string that you want to search for, and if it happens to be unique, you are in luck, because it will basically bring down the problem space to a very narrow lane, so to speak. So here, let's go ahead and search for something called Sunnyvale, which is where you work. So Sunnyvale happens to be a term that I have given in one of the nodes associated with the project. Remember, the nodes is always associated with the project. You can take nodes for any of the. Basically, nodes is like your journal for a project, and it could basically span the entire project space. So it can involve the crawl sites. I mean, you can take nodes for a given site, or a session of the um, or a crawl session of the site. Um, uh, Tag names, labels. Basically, it's like, it is associated with the project, and it can be meaningful only at the project level, not at the site level. Okay, even if you want to uh, say something about a specific site in a specific project, you can always do so in the project node section. So the search term is um, is always the search is always done in lowercase, and basically it is done via the regular expression module of Python, and we don't do substring search. Okay, we actually do a very strong regular expression based searching, and before we search, we also make sure that we remove all the stop words from the search terms. This is similar to the Google search. It removes all and, or, the, you, we. Those kind of stop words are present in the removal of that stop words is a pretty common thing when it comes to searching. And to do this thing, we use NLTK in Python. So I'm going to explain the details in a bit. So let me go ahead and search for Sunnyvale. And this is how the search results look like. So the projects, there are no results in the projects. I just wanted some comedy to be present in this thing. So I took some liberty here in saying that there is no search. I mean, there is no string present in that particular aspect of the Sherlock artifact. For example, if there are no search string, if there is no string in the project, I'm saying that no, there are no results in the project. The same thing if there is no if the name doesn't match with any of the crawl site name, I'm saying there are no results in the site web. So basically, I'm saying that it's a collection of something. That something happens to be this Sherlock object. The Sherlock object is a project, site, downloaded files, notes, labels, and tags. So I'm saying I'm giving various names to these collection of these Sherlock objects. I'm saying file, I'm saying stable, I'm saying web, so on and so forth. So don't be confused about the terminology. The common sense prevails here. The common sense is that I have not found any meaningful result in that particular Sherlock object. So um, so there are no file names with that particular search string. And the search string I'm searching for is always a standalone search string. It is not part of the substring. I mean, it's not part of a string. Like for example, I'm not like for example, let's say supervision. Okay, supervision. Now, if you're searching for vision, then I'm not showing any results which contain supervision. Okay, so I'm only showing the results if that result happens to have vision as a standalone word. Okay, it could be in in conjunction with any other words, but I mean, for example, if it's a medical journal and if it is describing about vision and all of those things, obviously there will be a lot of um, there'll be a lot of terms which are dealing with vision and vision itself, right? So I'm only showing the word as a standalone word. It doesn't go inside the string and search for the occurrence of the search string inside that string. Okay, so that is called a substring search, which I'm not doing, and I guess you don't want that to happen as well, right? So, anyways, in the notes section, I'm showing there is a relevant hit here, search hit, and the search hit is my name is Paul Starrett, and I'm a lawyer and I live in Sunnyvale. Now, as you can see, the case doesn't matter here. It could be lowercase, uppercase, mixed case. It doesn't matter. So everything is done with by ignoring the case. Okay, and at the same time, you would want some context to be given. Like if I simply tell you, okay, I found something in that particular notes, but it would be meaningful for you to get some context. So the context that I'm giving here is the name of the project in which this notes is present, and also the date on which you have added this notes. Okay, so that gives a bit of context to you, and you can see this line is basically a divider between list of search results. Okay, let's say for example, if you have two search results, then there will be two lines. Okay, and the star line is basically the one which actually divides Sherlock objects, like for example, file objects and notes object and crawl sites and things like that. Labels, obviously, there is no there are no search results in this in the labels objects, um, and the same thing goes for tags as well. So if I want to quit, I can simply say N, and if I want to do new search, I can simply hit enter. Okay, there you go. I'm asking for a new search term here. So again, so we were searching for Sunnyvale, and fortunately we got something in the notes section of one of these projects. So let me search for something called hacker. A hacker is a term which I've given um, yesterday. or was it day before yesterday? When I was crawling your website, I purposefully included a term called hacker in the raw text of the downloaded index page. Uh, Basically, I was testing the entire Scrapy thing, so I wanted to make sure that I get some data which actually differs from the previous crawl. So um, deliberately, I have included this term called hacker, and I guess I have taken down. I mean, I have given a label also for this particular session. Okay, so um, one thing that I need to tell you here is, the context actually differs from object to object. So, for example, if it's a project type object, a Sherlock object, um, there is no context is required. For example, the name of the project and also the date on which we have added the project would suffice. Uh, but when it comes to the crawl site, a crawl site could be uh, mm, could be duplicated across several projects. So um, some context is required. If I just give you the crawl site, it wouldn't make any sense. So the context that I'm giving here is the name of the project in which this crawl site is present. Now, for example, there could be several crawl sites. Um, Several crawl sites. There could be a crawl site which is duplicated across several projects. So wherever I see the name of the crawl site, I'm showing the project name also, and it goes without saying that I'm showing the dates. Wherever in fact, a date is a very important uh, information. So um, I'm showing the date added, um, date added, date found, and that kind of information to almost every search result. Okay, here I'm showing the date added because you added nodes. But when it comes to tags are found in the text. So date found. Okay, so that is the difference here. Label is actually given. So date given, I guess. That's what I've said in the code. Um, okay, so let me search for hacker. And as you can see, there are no projects, crawl site, downloaded files, nodes, which have this term, which has this term hacker. But there are labels. In fact, there is one label I found, and the label has found hacker on the page. Okay, that is the label that you have given. Remember, tags are automatically generated, labels are given manually. And um, session is basically the the times. It is an ID. In this case, it is an ID to the session table. Session is basically every run, every crawl of the website is a session. There could be multiple sessions for a given website in a day. It all depends on how granular you want to get, for a given website. But usually, I guess it all depends on how dynamic the website is. If the website is like like Twitter, then you would like to get um, you would like to get access to the Twitter stream um, almost like every hour or every 10 minutes or every 5 minutes and things like that. But if it's a blog, and if it's if it's one of those less trafficked sites, then probably you would do away with that kind of granularity, and you might say that get the blog content every 2 days or every 3 days. That's a bit advanced. We are not doing that in phase one right now, but it definitely has a meaning. It's meaningful to add that kind of duration when you're crawling for websites and trying to get meaningful data out of that. Okay, so that's what session is, and it's a session ID and date added. Okay, date added is such and such 18th or something. That is the date on which we have added this label. Um, Tags. Now I told you that um, I've added the term called hacker in the raw text, okay, of the page that I have downloaded, which means that automatically the tags will have this term. Okay, so I'm not showing the entire tag soup for that particular web page. It makes no sense because uh, tags are single words, right? So and I gave a single word uh, to search. So if I show the tag, I need to be showing the single word, the word itself, in the tag results, which is meaningless because I'm showing the search string and I'm showing the search string here as well. So I mean, there is no difference here because tags are basically standalone words, which means that they are like search strings by themselves. But in case of labels, nodes, project names, crawl sites, and downloaded files, they actually contain extra information. They are that search string is surrounded by some context, some extra text that will give you some information about what that particular search string is trying to convey, with that extra words which are surrounding it. I hope you're understanding. So basically, a tag is a standalone word by itself, and usually we are searching for the tag itself. I can say a tag or I can say a search string. Basically, it's one and the same. So uh, when it comes to showing the tag results, I'm just saying, okay, it is present in this project, this particular site, in this session, and on that particular day. But I'm not showing the tag itself because it's meaningless. The tag and the search string are one and the same. Okay, so I hope you understood what I said. Okay, now let's search for something which doesn't exist. So what happens then? Oh, I'm sorry. I'm really sorry. I should have pressed any key, so that's fine. Okay, so there are no search results. Um, there are no search objects which have this word called dolphin in any of the Sherlock objects, like for example projects or call sites or download files and so on and so forth. So I'm going to exit out of this thing right now, and I'm going to go back to explaining the code. Okay. Okay, fine. So let me go to Sherlock Core. And in Sherlock Core, I'm saying Sherlock Search. I need to go to Sherlock Search. Okay, so the most important thing is the NLTK corpus. Okay, so this is where you will start seeing the NLTK getting used, in some capacity. Okay, Sherlock model is the one which has all the database related stuff, and any code that deals with the database is present in Sherlock model. So um, we don't use database code, left and right in all the modules. That makes no sense, and it's going to be hard for anybody to maintain that piece of code. So have kind of centralized all the database code in Sherlock model. Okay. Now, you can see here that all kinds of search queries are directed to the methods which are present in the Sherlock model. Okay. Now, some of these methods will have similar functionality. Okay, and I guess you can, for example, you can look at the file names, nodes, file names, labels, and tags. All three of them have similar code. Okay, so maybe you can refactor these methods into a single method and have another parameter, another argument here, which tells you where I should be searching for. Should I be searching for the search? Should I be searching in the um, in the file names or in the labels or in the tags. Okay, fine. So so the first thing that I'm doing here in the Sherlock search is basically get the stop list from the NLTK. Okay, NLTK corpus. I'm downloading the stop words and then getting the English corpora and then getting the stop list, initializing the Sherlock util because I have to use the press any key method. So I'm doing that here, and this whole thing, the whole thing for asking for search is present in a while loop. Okay, so please enter the search term and or X to exit. I guess we can clear the screen here. The way we do it is sutil dot cls. I hope that's the right. I hope that's correct. Okay, so search term strip. Okay, this thing is basically removing the um, leading and trailing spaces, and I'm making sure that the search term is relevant and it is valid, and I'm checking whether the user has given X uppercase or lowercase, and if so, I'm breaking out of the loop. Um, New words is an array which contains non-stop list words from the search string. So basically, I'm splitting the search string, and then I'm removing all the stop words from the search string and putting them inside the new words array. Okay. Now, there is something that I need to tell you here. As of now, we are searching for a single word. So this may not be relevant. This piece of code, these two lines may not be relevant right now. But going forward, if you were to search for a phrase, it makes sense to have this piece of code. And at the same time, like you can search for multiple words. In Google or in any search engine, you can search for multiple words or phrases and that kind of thing. So what happens is the search engine um, takes the search string, and if there is a space in between these two words, it means that it has to search for both these words inside the text, inside the web page or text, and that kind of a thing. So um, unless you say or, okay, search for either this or that. Unless you specifically and explicitly mention to have an or search. Um, uh, Search engines will always look for the occurrence of both words in the text. Okay, so as of now, we are assuming that the user is always giving us only one word. Okay, it could be as long as he wants, but it's only one word. If there are like multiple words, if it's a phrase or multiple words or even a sentence, we basically do not care about that kind of things. So to make that work, to make to search for a sentence or a phrase or things like that which have more words, what you have to do is you join these new words. I mean, take the new words array and join all the words with and. Okay, and send it to database, and wherever you see and, you basically split it and then search for all these words. Okay, inside the text that you are searching. For example, the project has um, two words. Okay, if the name of the project has two words, then, and if your search string has two words, then you will be searching for those two words one after the other. Okay, only the projects which satisfy that criteria, like having two words, and if these two words match with the two words that you're searching for, only those project names are shown as part of the results. If the projects do not contain either of these words, okay, if they contain only one word, then those projects will not be shown. Okay, so um, um, I'm making sure that the new words array is bigger than zero. That means it should have at least one word. And here we compile the search string. Okay, slash v is the word boundary. Okay, which means that it always search for a standalone word. It does not search for embedded strings, embedded words. I told you about supervision, right? If you're searching for vision, then um, then the texts the text which contains supervision will not be shown to you. But if the text contains vision, only that text is shown. So all I mean to say is, substring search is not done. Okay, and then we initiate the Sherlock model, and then we call several methods which with the uh, compiled regular expression variable, and also the search term. Okay, and these are all lists. Okay, everything is a list here. uh, P names, CS names, P names standing for project names, CS is crawl site names, F names is the name of the files, um, nodes, labels and tags. Okay, and some formatting here. Okay, fine. Then we check whether the return lists are they greater than zero, which means to say that do they have valid results or not. If they have, then we display the project name and the date added and things like that. Wherever date is applicable, in fact, date is applicable and it is shown um, in all these Sherlock objects. Okay, so we do the similar thing here. File names, and basically it's the same thing done in a different way. Okay, so fine. So this is how it is. Um, let me go back to. Let me go to Sherlock model, which is the database class. This has the database class, and all the search methods are present at the back. In the very end of the Sherlock model. Okay, here they are. Search for project names. Here we have already written the project name. We have already written this method called get projects earlier for one of these Sherlock functionalities. So we we write on that pre-existing functionality and make sure that if any of the project names have match with this search string. Okay, so this is where we are doing it. We are searching for the uh, string in the project names, and then if there is a match, we add the name of the project. We add the project record of the project to the project list, PRJ list. This kind of thing happens across all the methods that are searching for the search string. Okay. Um, in some cases, there won't be, for example, if you're searching for, you're searching in the sessions, okay, in the downloaded data. In that record, you do not have project name or the crawl site name, okay, or even the date. So these three values are scattered across three tables, and then we actually get those values from those three tables. So let me show you. For example, search for file names. Okay, now projects info is the table, and it contains all the downloaded data for all the projects. Okay, now it has the URL, it has the PID standing for the project ID, and what we do is we check, we get the name of the project here, okay, right here. Similarly, there is something called CSID. crawl site ID. So for every record in the projects info table, we actually talk to three other tables to get the relevant information. Why we are doing like this? So we are doing it because relevant data for a given object stays in a single table. For example, all the projects stay in a projects table. All the crawl sites stay in the crawl sites table. Nodes, similar. It has a project nodes table. And the sessions, there is a project meta info table. And all the downloaded data, it stays in the projects info table. Okay. So, and then we get the crawl date, and this crawl date needs to be formatted. Okay. So that's how we do it. Search for labels, and the comments are not available here, but it is so simple that not having comments is actually a good thing. So it's pretty much self-explanatory what I'm doing here. But if you insist on having comments, I would certainly do so. I would comment out these files. In fact, you know what? It's a good thing that we add comments. Um, okay, search for nodes. This basically ends the list of search methods for Sherlock search functionality, the Sherlock. Okay, and search for tags, search for labels, and search for file names. I'm not checking the raw text that has been downloaded because it makes no sense. The reason why it doesn't make any sense is every raw text actually gets transformed to a tag cloud, right? So, and this tag cloud does not have any stop words. Stop words are like you, me, and the, I, our, those kind of words are stop words, and we remove them, and we make sure that we get a unique tag cloud for every file that we download. Okay, so raw text, it exists for a different situation. For example, you want to see, if you look at the tag cloud, it doesn't make any sense to you because those are not sentences, those are not paragraphs. um, Tag cloud exists for a reason, and that reason is to quickly search for a given word in the text. Okay, so, and Sherlock search does the same thing. It does not look for the word in the raw text. Okay, it does so in the tag cloud because it's faster and it's easier and foolproof. Okay, but in future, if you want to look at the web page, how the web page actually has changed, did anybody add the data to it, how did they add it, what kind of data was added, when was it added, that kind of investigative thing can be done by looking at the raw text, not at the tag cloud. Okay, so I hope you understood the reason why we don't look at the raw text. Okay, project names. It might sound a little bit far-fetched to search for the project names and site names and file names as well. The reason why I'm doing these three searches are, um, see, it's a text that you're trying to search, and wherever this text is used, for example, if I'm downloading the file names, if I'm downloading HTML files from the website, these HTML files will certainly have a path. That path actually becomes the name of the file locally. So um, you might be interested to see what kind of data is present in that file. But if you if you just remember the name of the file, it's a lot easier for you to search on that. Similarly, same thing goes for the project as well as the crawl site. So um, this is all extra information for you to understand that wherever text is used, um, we can search for that particular text in Sherlock search functionality. So this completes the the search video. Okay, and I guess we have covered both the front end and back end here. So um, the next video will deal with diff uh, between any two sessions of a project. Okay, so watch out for that video, and thanks for looking at this video.